Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, we're going to be dealing with rules for pumps. Rules are boundary conditions that are available for pumps, lateral structures, and inline structures. This exercise is going to be using them for pumps. All right, what I have on the screen here is my HEC RAS with the geometric data editor open up down below. I'm going to start by going File, New Project, and then go ahead and navigate to the directory you want to save that project in. Okay. And then over here in the left side, type in a title for the project. Just call this one Exercise 24. You can call your project whatever you want for the title, and then click OK. And then here we just want to accept the unit system and click OK. All right. First things first, let's go ahead and sketch out our geometry, specifically the river reach. So I'll just do a single left click and then add some more clicks and then double click to end. I'll give that river a name and the reach a name. All right, next I'm going to click on the cross-section data editor here and start by creating a cross-section down here at the bottom of the reach. So I will go Options, Add New Cross-Section. This will be for River Station 0, which is at the bottom of the reach. Click OK. Okay, the station elevation data here, I'm just going to paste in, or you can just type it in yourselves. The downstream reach length, the Manning's N, I'm just typing in some typical values here. The left bank over station is going to be 30 for the left bank, and then on the right bank, it'll be 60. Okay, if I click Apply Data, I now have a little preview of that cross-section over here to the right. Next, I'm going to add a couple more cross-sections. So let's go ahead and go Options. I'm going to copy the current cross-section. The next one is going to be 2,000 feet upstream. Okay, so I just need to add that length here to the downstream reach length. And then I'm also going to add a little bit of elevation. So I'll just say 2 feet. That'll be a 0.1% slope. And then apply. I'm going to do that one more time, 2,000 feet further upstream. So copy the current cross-section. This will now be River Station 4,000. And then once again, I'm going to add a couple feet. Adjust elevation to, okay. Right, apply data, plot. We can see the profile plot right here. So we have 3 different cross sections, constant slope. I'm going to close that up. And then I'm going to also add in some intermediate cross sections. So I'll go Tools, XS Interpolation within a reach. And then I'm just going to say every 500 feet. And then interpolate and close. All right, so I've got cross sections every 500 feet now. Next, I'm going to add a storage area or a couple storage areas right here. So I'll click on storage area, and then I'm just going to single left click and then continue doing left clicks to kind of give some curvature to the boundary between the water and the land. Storage area 1. Okay. Storage area 2 coming in, single left clicks right there. Double click to stop, and then storage area 2. I'm going to define the geometry of these 2 storage areas by clicking Edit Storage Area. And then I'm just going to paste in the geometry here. So paste. I had it saved on my clipboard. So there's the data. And then I can also get a plot of that data. I'm going to go ahead and make the same change to the storage area 1. So both these storage areas will have the exact same geometry just to keep things simple. Then if I scroll up to confirm the numbers pasted in, yep, there they are. There's the plot, and okay. All right, before I forget, I'm going to go ahead and save my geometry file. So File, Save Geometry Data. I'm just going to give this the title of data, or how about base? Base is good, okay. And a few things need to happen. What I'm also going to do here is add a lateral structure, which will have a tailwater connection to storage area 1. And then I'm also going to add a pump, which will connect storage area 1 to storage area 2. The lateral structure, I'll do that first. I'll click on lateral structure here and then add a lateral structure. This is going to be at River Station 2900. That'll be the upstream edge of the structure. I'll click OK. This is going to have a headwater position of next to left bank station. And then the tailwater connection, like I said, is going to be for storage area 1. Okay. Next, I'm going to define the weir here. So I'll click the weir. And then let's see, the weir width I'll say is 50 feet. The distance from the next upstream cross section is 100 feet. And now I need to specify the station and elevation data. So I'm just going to type some numbers in here real quick. Okay, so I got those numbers typed in. It is a 300-foot long lateral structure. And then the invert here for the weir is 204 feet. So let me click OK. Here it is, just in all its glory. We have a 100-foot wide weir, so plenty of weir, and it's almost the same as the channel invert. Let me go ahead and show that. So if I close this, if I open up the lateral structure, here we go. So we can see that this ground elevation here is the channel invert. And then the bank station right here is the red lines, or the two dots, which could be connected with line. All right, so the last thing I need to do for the geometry file here is to add a pump station. So I'm going to click pump station. I'll put it right here. It's going to pump water from storage area 1 to storage area 2. And then let's see, this is asking for a name, so I'll just call it pump station 1-2. So I know it's pumping from storage area 1 to storage area 2. All right, let's go ahead and define the pump station properties here. So the first thing it wants to know is what is the inlet connection? So that's going to be a storage area 1. The tailwater connection is going to be to storage area 2. Okay. The next tab over here is the pump group data. So I'm going to sort of disable the on off switches here because I'm going to define that in the rules, not the geometry data. And then for the pump curve here, I've got a pump curve data saved onto my clipboard. I just I copied it from Excel, and then this is what it looks like. You can use my numbers if you want to follow along or make up your own pump curve data. So click this button here. I can just double check that I didn't make any typos, and it looks like a typical pump curve shape. All right, so I'll go ahead and close that and then go File, Save Geometry Data. We're ready to add some flow data and then run the simulation. All right, so to do that, I'm going to go up to Edit and then Unsteady Flow Data. I've got a couple of boundary conditions here. I'm going to set the downstream boundary condition and just use normal depth and then use the channel slope of 0.1%. And then for the upstream boundary condition, this is going to be a flow hydrograph. I'm going to use the enter the data in this dialog box right here, enter table, and also use the default selection of use simulation time. And then also I'm going to use the 1 hour time step, and then I'm going to paste the data in right here. I just went over to Excel, copied it onto my clipboard, Control V to paste. It's a 3-day simulation, and the flow rate starts at 1000 CFS. Here's the plot. It ramps up to 10,000 CFS and then back down to 1000 CFS. So that's what we're going to be doing here. Okay, so I'll click OK to that. And then one more thing I need to do here for boundary conditions is set the initial conditions. This is going to be this initial conditions here of my 2 storage areas. So I'm just going to start them empty. I can click the button here. That means they both have an invert of 200 feet, which means they'll start with no volume. All right, so I can go ahead and save this unsteady flow data. I'm going to go File, Save Unsteady Flow Data. I'm going to go ahead and name this No Pumping and then click OK. So right now there's no pumping involved. If I go back to my boundary conditions, I can add a pump station, and I will, and it will use rules. But for this first trial, I like to just do a practice run without anything fancy, just to make sure that the model works. So we will get some flow into storage area 1, but not to storage area 2, because the pump is the only way water can enter storage area 2. So let's go ahead and close that. Click on the stick figure running up a hill, which is the same as Run Unsteady Flow Analysis. It brings up this dialog box right here. The geometry data is the base file, and then no pumping file for our flow file. I'm going to go ahead and save these two together as a plan. So File, Save Plan. For a name here, I'm going to call this just No Pumping, and then click OK. For the short ID, I'll also use No Pumping. Now I need to check on here the programs to run. So I'm going to run these 3. And then I also need to define the duration of the simulation. This is a 3-day duration, and I most always just use the first 3 days of the year 2020. All right. Also for the output, I'm going to change this to 15 minutes. I just sometimes think the extra detail is nice to see here, and that looks good. So I'm going to go File, Save the Plan, and then Compute. All right. So the simulation ran. There was a warning up here, extrapolation on the H-tab vertical discretization, I believe. One moment here. Back to the geometry file. I'm going to click on this H-tab parameter. Yeah, it looks like I may be using too much flow for this model. 1 second. Okay, I figured out what was going on here. What I want to do is change the flow file. Here's the unsteady flow hydrograph. And then now this is the plot that I'm going to be using for this exercise. We have a constant flow of 100 CFS. It ramps up to 1500 CFS and then back down to 100 CFS. File, save unsteady flow data. I can close that. Now let's go ahead and run that simulation. Compute. Okay, so that ran fine without any problems. Let's take a look at some results. Water surface profile, and then options, animate. Here we have the constant 100 CFS. It ramps up to 1500 CFS. You can see there's going to be plenty of flow through that lateral structure. So let's take a look at that lateral structure now. I'll close this. View. I'm going to click on the stage and flow hydrographs. And then for the type, I'm going to click on lateral structure. This is our one and only lateral structure right here. And I'm going to also toggle off the stage data and the observed data. What we have here is 3 different plots. Let me go ahead and modify the symbology so we can see it a little easier. Okay, what we have here in red, this is the water in, let's see, just upstream of the lateral structure. And then in blue, that's the flow just downstream of the lateral structure. We're dealing with the flow rate here. And then green here is the flow rate into the lateral structure from the main channel into storage area 1. So you can see for the first part of the simulation, there's a positive flow. This green line here is positive. And then in the second half of the simulation, the storage area has a higher water surface elevation than the channel, and then we have a negative flow value here. What's going on with this little spike right here? I can't explain it at the moment, but maybe we'll find out. What I want to do in this exercise is to develop pump rules so that we pump the water from storage area 1 to storage area 2 so that we can reduce this tailwater elevation downstream of the lateral structure. And at the same time, I want to keep the water surface elevation in the 2 storage areas about the same. So let's take a look at this elevation here. We can go to type and then storage areas. Here's storage area 1. We need to toggle on the stage here. And then actually I can toggle off the plot for the flow rate. This is the stage of storage area 1. It looks like it gets up to about 211 feet. And then for storage area 2, that should just stay at the bottom at 200 feet. Yeah, because there's no water entering storage area 2. Okay, I don't need to look at the pump because it's not pumping anything. Let's carry on with a pumping operation now. So I'm going to go ahead and close this. Next, I'm going to go up to Edit, Unsteady Flow Data. Now, for the boundary condition, we want to add a pump station. So our one and only pump station, which pumps water from storage area 1 to storage area 2. We're going to add that and then click there, click on Rules. All right, so now it's time to define our rule set for this pump station. I'm going to click the Enter Edit Rule Operations button. And what I'm going to do is just set the flow rate or turn the pump on and off. So let's get started here. I'm going to start with a comment actually, and this is going to say get data. And then down below that, I'm going to get the water surface elevation for both storage area 1 and storage area 2. So to do that, I'll click on get sim value. This is going to be a new variable. So I'll type in WSELSA1. And then over here, I'll click on storage area. And I want water surface elevation for storage area 1 at the current time step. That looks good. All right, I'm going to click on the next row down and basically do the same thing here, but for storage area 2. So get sim value, WSELSA2, and then water surface elevation, storage area 2 of the current time step. All right, it's time to turn on the pump. So I'm going to add a new comment here that just says pump operation. And then below that, what I want to do is start off with an if-else statement because I don't always want the pump running. It will be based on the relative water surface elevations between these 2 storage areas. Okay, so I'm going to click on branch if-else. And I'm going to go with the if, yeah, let's go with this first one, if then. And then below that, I want to go with an else if. No, actually, I just want an else. Okay, and then after that, I want an end if, which is right here. Okay, let's go ahead and provide the condition here. So the first value is going to be the water surface elevation in storage area 1. If that is above the water surface elevation in storage area 2, and then I'm also going to add a little buffer like 0.1 feet and click OK. Then I need to define what happens. That's going to be turning on our pump. So I'll click on Set Operational Parameter. And now I have all my different operations for the pump station here. I'm going to turn pump on. Next, I need to specify which pump group and then which pump. Now, I only have one pump group and one pump in that pump group, so that data is already selected for me. And yeah, that looks good. After that, I want to also specify the pump should turn off if this condition is not true. So I'll click right here. I'll click on Set Operational Parameter and then Turn Pump Off. And again, it's my only pump group and my only pump. So let's go ahead and see how that works. Obviously, we should have some flow and some water into storage area 2 now. So I'm going to click OK and click OK. We want to save this. Oh, this is the no pumping operation. I need to save this as pumping. So let's go File, Save As. I'm just going to change the name here to pumping. So I'll click OK. So I'll close that. Then let's go ahead and run it. So plan here is also going to be pumping. I'll save the plan. The title is going to be pumping. OK. The short ID is going to be pumping. And let's go ahead and compute. Okay, so the simulation ran. It appears there was no errors and no warnings. So let's go ahead and take a look at some of those results. I'm going to go straight to the stage and flow hydrograph results here. And then for the type of data, I'm going to take a look at how about the pump stations? Interesting. So what we have here is the headwater and the tailwater. And then we have the flow rate, which is the flow through the pump. What I can tell from this plot here, the headwater is in blue, that's the stage, and it looks like the water surface elevation maintained the same elevation for both storage areas for the first 2 days or so of the simulation. And then after that, it looks like the tailwater stays here at the top elevation because there's no way for it to leave. But then the headwater, referring to storage area 1, we could think of the storage area 1 as the headwater, storage area 2 as the tailwater, HW, TW. Yeah, the storage area 1, which is this blue line here, that elevation began to drop because the water surface in the main channel began to drop, and the flow through the lateral structure was now back into the channel from storage area 1. Let's go ahead and confirm that by going to View and then Profile Summary Table. Now I'm going to click on the Lateral Structures table right here, and I'm going to toggle on all the profiles. So Options, Profiles, select all. Then I'm going to toggle off the max, click OK. Right here is the flow going into the storage area. So leaving meaning leaving the channel. It starts off kind of low and then it ramps up here 200, 400. It looks like the maximum is around 560. And then let's see, if I scroll down further, the flow rate begins to drop. And then finally, the flow is going the opposite direction here. So let's go ahead and just take a look at that plot. I'm going to come back to this plot because there's something else I want to do, but let's go to lateral structures plot. And then I'm going to toggle off the stage in the observed data. Okay, I'm going to change the colors too because it's kind of hard to say. Oh, look at the green line. Yeah, I've added some colors to make it easier to see. Red here is the flow rate in the main channel. And then the green line here is the flow through the lateral structure into storage area 1 from the main channel. And you can see how the blue line is basically the difference. So as the green line is positive and there's flow into the storage area 1 from the main channel, that's why the blue line or the downstream flow in the main channel is less than the upstream, and then vice versa once that storage area 1 is emptying out into the main channel in the last day of the simulation. All right, I mentioned I wanted to check out that plot one more time for pump station. All right, here's the pump station data. And basically it's turning on and off a number of times here. And then finally it's on for a steady, 16 hours or so. And then it's turning on and off again. I'm going to turn on the stage data here. So we saw this already. But what bugs me is the fact that this pump is turning on and off all the time. I can go ahead and take a look at that data as well. Going to the pump station table. Here the pump turns on, it turns off, it turns on, it turns off. This is 15-minute time steps here. And then on and off and on and off. And finally, it stays on for a good while until it's toggling on and off again. So what I want to do in the last part of this exercise is to hopefully smooth out that pump operation. And we're going to do that by modifying our rules. So I'm going to go back to the Edit Unsteady Flow Data. And this time I'm going to remember to save it as a new file. So File, Save Unsteady Flow Data As. I'm just going to call this pumping 2 because it still will be involving pumping, but won't be the same as our first rule set. All right, so I'm going to double click on rules, enter/edit rule operations. What I want to do here is add a variable up at the top, and this is going to keep track of the flow through the pump. So to do that, I'll just go ahead and go get sim value. This is going to be a new variable here. I'll just call it Q pump previous. And then let's see, pump station should be a category. There it is, pump stations, and then station pump flow. I only have one station, but I do want to select the previous time step here. So this is not a concept or an activity we've used in any of the previous exercises yet. But what I want to do is keep track of the pump, and if it's pumping, and only turn it off if it's gone down to a certain elevation, or not elevation, but elevation with respect to the water surface elevation. So this operation does require rules. It's not something you can just hard code into the geometry data. Now I'm going to modify the rules down here. So right now, if the water surface in storage area 1 is over 0.1 feet above storage area 2, it turns on, but don't want to turn it off necessarily once that statement's not true. What I want to do is add another statement, which is else if and or then, and then I also want an else as well. So let me click on this, boom, and else. Okay, so I just pushed that down a little bit. Now I need to set this condition, and this is going to involve the pump previous flow rate. So as before, I'm going to use the first part of the first condition again. So this is going to be water surface elevation, okay, and that's greater than, and then the water surface in storage area 2, okay. And notice I'm not going to be adding in this plus 0.1. But what I want to do in the and clause, the second part of this condition, is check to see if the pump previous value is positive or not. So it's going to be pump previous, okay, and then greater than, and then just the constant value of 0. Okay, so if that is true, then what I want to do is turn the pump on, or rather it would just stay on. So I could really just do nothing. But to be complete about things, I'm going to just go copy and then paste it right in here. And let's go ahead and see if that works. I'm hoping that will reduce the amount of on-off switches. And actually, I could change this 0.1 to a 0.2 or something higher even if I wanted to take it a step further. But let's go ahead and save and run the simulation and see if this makes any difference. So File, save the unsteady flow data, close, run, unsteady flow analysis. And this is going to be pumping 2. So File, save the plan, pumping 2, okay, pumping 2, okay, compute. Okay, so that looks successful. I'm going to click close now. Let's go ahead and take a look at the results view, and then let's go stage inflow profile. For the type, I'm going to click on pump station. Okay, looks like same problem as before. Let's see here. What I was trying to do here in pumping 2, this plan was to basically continue the pumping until the water surface elevation was equal again, and then turn it off. Don't just turn it on and off as much as possible. But I'll go ahead and take a look at that and get it fixed up. But anyway, that's it for this exercise. What we did was we created a HEC RAS model with a pump, and then we used the rules boundary condition to operate the pump in a very specific way that the user can customize to satisfy their system requirements.